Section 2 of this unit is all about angle pair relationships and transversals. When two coplanar lines intersect, they form four angles with special relationships. One of the relationships these angles may have is a linear pair. Linear pairs are two angles with a common side whose non-common sides are opposite rays, or more simply, two angles that together form a straight line. In this, we have four linear pairs. They are angle 1 and 2, angles 2 and 3, angles 3 and 4, and angles 1 and 4. Linear pairs are a special type of supplementary angles because they are adjacent to each other. They share a common side. This means the measurement of all linear pairs add to 180 degrees. Vertical angles are also formed by the intersection of two lines. Vertical angles do not have a common side, but their sides form two pairs of opposite rays. The angles have the same vertex, but they are on opposite sides of the intersection. We have two pairs of vertical angles, angles 1 and 3, and angles 2 and 4. Vertical angles are always congruent to each other, meaning they have the same measurement. If we add an additional line to our diagram that intersects one of the original lines in a new place, a transversal is formed. A transversal is a line that passes through two lines in the same plane at two distinct points. Here we see the transversal highlighted. Since the transversal intersects multiple lines, new angles are formed that have their own angle pair relationships. Not only are new linear pairs and vertical angles, but additional angle pair relationships are formed between these two intersections. The first relationship formed is corresponding angles. Corresponding angles occupy the same relative position at each intersection of the transversal. If we were to cut the intersection point out of one line and place it over the other line, the corresponding angles would appear on top of each other. I like to name each angle with a location, like angle 1 is the top left of its intersection. Then look at the other intersection and notice angle 5 is also on the top left. Therefore, these angles correspond with each other. Angle 2 and angle 6 are on the top right, so they correspond. Angles 3 and 7 are on the bottom right of their respective intersections, so they correspond. And angles 4 and 8 are both on the bottom left, so they correspond. An important property about corresponding angles is if both non-transversal lines are parallel, the corresponding angles will be congruent. Another notable angle pair relationship is alternate interior angles. Let's break that name down. Alternate is talking about different sides of the transversal. So this transversal has a left side and a right side. Alternate angles will be on opposite sides of the transversal. Interior means inside, so we were looking for the angles that are between the two lines. So angles 3, 4, 5, and 6 are interior angles. To be alternate interior angles, the angle pairs would have to be on opposite sides of the transversal and between the lines. So the alternate interior angle to angle 4 is angle 6, and the alternate interior angle to angle 3 is angle 5. Like corresponding angles, if the two lines are parallel, then the alternate interior angles are congruent. Alternate exterior angle pairs, like alternate interior angles, will be on opposite sides of the transversal, but now both angles will be outside of the two lines. Angles 1, 2, 8, and 7 are exterior angles, but the pairs that alternate the transversal are angles 1 and 7 and angles 2 and 8. Like alternate interior angles and corresponding angles, if the two lines are parallel, the alternate exterior angles are congruent. Consecutive interior angles, or same-side interior angles, are two angles that lie between the two lines, but this time they are on the same side of the transversal. Angles 4 and 5 are both on the left side of the transversal, making them consecutive, and they are between the two lines, making them interior. Unlike the other angle pairs we have talked about, if the two lines are parallel, the consecutive interior angles are supplementary. It should be obvious that they are not congruent considering in this diagram, the two lines appear to be close to parallel and angle 4 is acute and angle 5 is obtuse. They are not congruent, but they are supplementary as long as the lines are parallel. Here we have another example of angle pair relationships. This time, the two lines are clearly not parallel. In fact, they intersect if we just extended them a little bit more. But we still have the same angle pair relationships. We now know that they are not going to be congruent or supplementary to each other. So here, our corresponding angles, remember the angles that have the same relative position, are 1 and 5, 2 and 6, 3 and 7, and 4 and 8. 1 is the top left angle, 5 is the top left angle, 8 is the bottom left angle, 4 is the bottom left angle. That's what makes them correspond with each other. There's also alternate interior angles. Angles 2 and 8 are on different sides of the transversal. One's on the top, one's on the bottom. And they're interior of these two lines. So that makes them alternate interior angles. The other alternate interior angles are 3 and 5. Well, and they correspond. We also have alternate exterior angles. 4 and 6 alternate. They're on different sides of the transversal, and they're outside of the two lines, so they're exterior. And 1 and 7 also alternate on the transversal and are outside the other two lines. We also have consecutive interior angles 2 and 5. They are on the same side of the transversal and in between the two lines. So consecutive on the same side of the transversal, interior between the two lines. And 3 and 8 are also on the same side of the transversal, this time the bottom side, and they are in between the two lines. Let's use what we've learned to find some angle measures based on a transversal that we have pictured here. So if we are told that angle 3 is 110 degrees, we can actually find out what every other angle in this diagram is because we know that these lines are parallel to each other. So if angle 3 is 110 degrees, we know that angle 1 is also going to be 110 degrees because angle 1 and 3 are vertical angles. We can figure out that angle 2, well, we can figure out what angle 2 is going to be because we know that 2 and 3, these two, form a linear pair. So they add up to 180 degrees. So we can just do a simple equation to figure out 110 plus the measure of angle 2 equals 180. And if we subtract 110 from both sides, we'll get the measure of angle 2 equals 70 degrees. Now, since we know that all these angle pair relationships are either going to be congruent or supplementary, all of our other angles are either going to be 110 degrees or 70 degrees. Since we know that angle 3 is 110 and angle 4 is a linear pair with angle 3, we also know that angle 4 is going to be 70 degrees. It's also kind of obvious because angle 4 is definitely acute, and if angle 3 is obtuse and 110 degrees, it's probably going to be the 70-degree measure. Then angle 7, this one down here, this corresponds with angle 3. And since the lines are parallel, they will be congruent to each other. So angle 7 will also be 110 degrees. Angle 5 is an alternate interior angle to angle 3. So that will also be congruent. It will be 110 degrees. Angle 6 is a consecutive interior angle with angle 3. So they're not going to be congruent to each other, and they don't look congruent, so that's good. But they are going to be supplementary, so that will be 70 degrees. And although there's no special relationship between angle 3 and angle 8, angle 6 and angle 8 our vertical angle, so we know that angle 8 is also going to be 70 degrees. All right, here is just a neater version of what I wrote on the previous slide, and it has the reasons why each of them have the measurement that I gave them. So measure of angle 1 is a vertical angle to measure of angle 3. 2 and 4 are both linear pairs to angle 3. Angle 7 it corresponds with angle 3, and the lines are parallel, so those are going to be congruent. Angle 5 is an alternate interior angle to angle 3, so they're also congruent. Angle 6 is a consecutive interior angle, so they're supplementary. That's why it has the 70 degrees. And I got angle 8 by using the vertical angle to angle 6. So those should be congruent to each other. They're both 70. Let's try another example. If the measure of angle 2 is 65 degrees, we got to find all of the other angles. So we can find the measure of angle 1. Well, that's a linear pair with angle 2. So 65 plus the measure of angle 1 equals 180. And if I subtract 65 from both sides, I get the measure of angle 1 equals 115 degrees. Okay, the measure of angle 3, that's also a linear pair. I don't have to do the math again. I know that is also going to be 115 degrees because it's a linear pair with angle 2. Measure of angle 4 is going to be 65 degrees. That's a vertical angle with angle 2. So they're both going to be congruent to each other and have the same measurement. Angle 6 is a corresponding angle, so it is going to be congruent. That's going to be 65 degrees. Angle 8 is an alternate exterior angle. Alternate exterior angles are congruent, so that is also going to be 65 degrees. Angle 7 is a consecutive exterior angle. We didn't go over this one, but if you just switch the words around a little bit, consecutive exterior angles are going to be supplementary, just like consecutive interior angles are. So that would be 115 degrees. And remember, when you're in doubt, angle 7 is obtuse, angle 2 is acute. They can't be congruent. They're probably supplementary. And angle 5 doesn't really have a special title that goes with it, but I know that angle 7 is 115 degrees, so I know its vertical angle 5 will also be 115 degrees. Let me give you a cleaner view of this with the reasons. Now that we've gone over a few angle pair relationships, it's time for you to try it on your own.